Okay, lesson 1-5, infinite limits. As a warm-up, please sketch the graph of each function. Refrain from using a calculator. And we'll go over what those graphs should look like in class tomorrow. Okay, couple definitions. An infinite limit is a limit that increases or decreases without boundary. So if something, all right, if we're talking about limits, then we're describing the y values. If a y value increases without bound, then it would approach infinity. If it decreases without bound, then it would approach negative infinity. We know that if we have plus or minus infinity as an answer, the limit itself does not exist. Furthermore, we've looked at one-sided limits as well. Now we're going to define what a vertical asymptote is using one-sided limits. So a function has a vertical asymptote if its limit as x approaches c from the left or its limit as x approaches c from the right is positive or negative infinity. If either one of these conditions is satisfied, then x equals c is a vertical asymptote. Okay, if a vertical asymptote occurs, it does so at a domain restriction. Okay, an asymptote is a type of discontinuity. So if it's a vertical asymptote, it occurs at a domain restriction, but now it has to have that infinite one-sided behavior. Okay, so the limits from either the left or the right have to approach positive or negative infinity. And that's exactly what the definition says there as well. All right, finding vertical asymptotes, given a rational expression, okay, rational meaning numerator and denominator. A vertical asymptote exists at x is equal to c if f of c cannot equal 0 and g of c can equal 0. Okay, so I just said, where does a vertical asymptote occur? It occurs at a domain restriction. What do domain restrictions identify for us? The fact that a discontinuity occurs on the graph of the function. So we're doing the same thing that we did in lesson 1-4. Identify the domain, attempt to find the limit. Now, think about this question for me. What if f of c equals 0 and g of c equals 0? Okay, so we have here the vertical asymptote occurs if f of c isn't 0 and g of c is 0. So think about this for me, and we'll discuss that in class tomorrow with the warm-up. Okay. Find the vertical asymptotes, if any happen to exist, of the graph of the function. F of x equals 1 over x squared. Okay, so like I had said, our method in lesson 1-4, discontinuities. Determine the domain. The domain is that x cannot equal 0. Secondly, attempt to find the limit. Limit as x approaches 0 of the function. Direct substitution gives us number over 0. Because direct substitution gives us number over 0, we know that the limit does not exist. In order to answer the question if it's a vertical asymptote, however, we need to look at the one-sided limits. So now, limit as x approaches 0 from the left-hand side. Go 1/10 to the left, so imagine plugging in negative 0.9. Then, plugging in negative 0.1 rather, I would have a positive numerator and a positive denominator. Therefore, the one-sided limit would approach positive infinity. From the right-hand side, plugging in positive 0.1. So when you plug in positive 0.1, I would have a positive numerator, positive denominator, so then my one-sided limit from the right would be positive infinity as well. Okay, so what is the difference between these problems and what we did already? The problems of attempting to find a limit, if this is just what I gave you as the question, limit as x approaches 0 of this function, the function does not exist, because direct substitution gives us number over 0. Which is a very valid case. It says it's a non-real answer. Now when we're attempting to identify why or where a vertical asymptote occurs, we look to the one-sided limits. Because the one-sided limits have this infinite behavior, we can conclude that a vertical asymptote exists at x is equal to 0. Why x is equal to 0? Because that's the domain restriction. G of t equals t minus 1 over t squared plus 1. Domain, t squared plus 1 equals 0. Subtracting 1. No domain restrictions. Since the domain is all real numbers, there can't be a vertical asymptote on the graph of the function. All right, next. X squared minus 2 all over x squared minus x minus 2. Right, so first things first, find the domain of the function. And I'm going to factor the denominator so we can find the domain more easily. So the domain, x can't be 2, x can't be negative 1. Domain, limit, conclusion. So now let's find the limit as x approaches 2 of the function. When we plug 2 into the function, direct substitution gives us number over 0. So this limit does not exist. In order to discuss vertical asymptotes, though, we want to look at the one-sided limits. Okay? So into my function, if I were to plug in 1.9, square that, and subtract 2 from it, I would get a positive value. Divided by, look at 1.9 in my factored form. 1.9 minus 2 would be a negative, times 1.9 plus 1 would give me a positive. So this behavior would approach negative infinity. 2.1 squared minus 2 would give me a positive number, and then plugging into both factors in the denominator, they'd both be positive. So the one-sided limit from the right would approach positive infinity. What can I conclude from the one-sided limits? A vertical asymptote occurs at x is equal to 2. 2 domain restrictions, 2 limit statements. Limit as x approaches negative 1 of the function. Direct substitution gives me number over 0, so the limit does not exist. Now let's look from the left and the right. Negative 1 from the left. And then x approaches negative 1 from the right. Plugging into the left of negative 1 into the numerator would give me a negative numerator, and both factors on the denominator would be negative as well. So the one-sided limit would approach negative infinity. Negative 1 from the right-hand side would give me a negative numerator. My first factor would be negative, my second factor would be positive. So from the right of negative 1, I would approach positive infinity. So what can we conclude? Vertical asymptote at x is equal to negative 1 as well. Okay, f of x equals x cubed plus 1 all over x plus 1. Domain first. Okay, so one thing again that we talked about in section 1.4. Domain, limit, conclusion. Domains always have to come from the original function. So my domain, x can equal negative 1. Now when we attempt to find the limit, direct substitution gives us 0 over 0. So what does that tell us? Algebraically, the function can be simplified somehow. All right, x plus 1, x squared minus x plus 1 all over x plus 1. I get my 0 over 0 terms to cancel. So now I'm just substituting -1 into my quadratic, and I get a limit of +3. So what's the conclusion? No vertical asymptote occurs, okay? Why isn't a vertical asymptote? Because instead it'll be a hole at the point -1, 3. Remember the difference here. Vertical asymptote is a non-removable discontinuity. A hole is a removable discontinuity. What separates these two categories? The existence of a limit. Limit as x approaches -1. We were able to find a limit. That's why the vertical asymptote wouldn't exist on the graph of the function.